Welcome, so many of you rolling in right now. Today, we are going to talk about battery energy storage systems, such an exciting topic. My name is Amy Dix. I am the director of marketing here at Myers, and we're going to kick this off. Here's the good news today. I am not the one that you get to listen to for the next 60 minutes. We have far more intelligent folks on with us here from Myers today that is going to present to you. John Rimbos, our Vice President of Sales and Marketing. Happy to have him leading us and kicking us off here in just a moment. We have AJ Friesen, the Vice President of Energy Solutions. Always a great day when AJ can be on a webinar and give us all the knowledge about BESS. And we have Jennifer Lawrence, Regional Business Manager of the West Coast. So with that, I will turn it over to John and he can get us kicked off.
All right. Thanks, Amy. Hard to match that energy level, but I'll try. So, this session is really meant to focus on understanding the opportunity and the solution of a battery energy storage system, not the detailed system design or engineering. That will be a separate webinar and or course that we conduct. So today we'll cover, why energy storage? Why does it make sense? The fundamentals, the value proposition of these systems, the high level system topology, and really where the market is headed. About Myers a little bit, for those of you that are not familiar, and most of your agents, so you are, but for over 60 years, we've been doing these backup power systems. And our core is the life safety products, which are the inverters and controls. And that's really our legacy. In fact, people know us as the lighting inverter, the emergency lighting inverter. But that's not all we do. And while that's required by building code, there are other loads that we can do and back up. And so, for example, in life safety, you have to have ventilation backed up. That needs to be backed up within 60 seconds of a utility power break. And so, loads such as ventilation, like exhaust fans in a data center, or building access systems like automated doors, key card readers, facial recognition, or even turnstiles that you go into large buildings with, those are all things that need to be backed up. And so those are things that we can do with an inverter. Inverter is essentially batteries in a box with intelligence that hooks into your system. Following this timeline here a little bit, in 2019, we acquired a controls company named LVS Controls that's out in California, and that helps our inverters get smarter and more architectural freedom is allowed for the designers. So if you're an agent, you're dealing with these different designers, that flexibility to take that RCP and make it look different, maybe less labor intensive, maybe better acquisition pricing, and maybe better uniform illumination along the path of egress. We can achieve that by using the controls on top of the inverters. And so we want to kind of continue along that line of thinking here when we get into the battery energy storage. So in 2024, we purchased a battery energy storage manufacturer named SPS out of Canada, and we branded it with BES you're going to learn about today, which is Entershed. Entershed's the name of our BESS. And we actually took the production and moved it to Pennsylvania last year, which makes us one of the few that has US content north of 70%, and we're fiat compliant. So meaning we can do BAA, BABA, and TAA, and that's important in this space for several reasons that we'll share with you today. And then in the summer of 2020, we acquired an energy management system, which Jennifer's going to tell you about later. And that really is the brains. These units in themselves are dumb, right? They're batteries in a box, but when they're told what to do, you can do a lot with them. And that's what we're really excited about because now we can do some things for your customers to save them money and take them to a different position from an energy perspective. If you look at what the challenges that businesses face today, this grid, this electric grid, wasn't really built for today's reality. And you think about AI and all the things that are happening in this space, it's just going crazy right now. And a lot of grid instability is out there. So businesses are dealing with rising energy costs, more frequent outages, increasing instability as the demand grows, and then renewables add variability into that system. So what do we do with all that? And that's what we're kind of talking about here today. Because electricity has to be used the moment it's generated, any mismatch between supply and demand drives higher costs and reliability risk. So that timing challenge is best illustrated by something we call the duck curve. So this is a graphic on the duck curve because it looks like a duck, right? Simply that's the reason it's got the head of a duck. And we'll show you an actual duck curve in just a few minutes with the energy and the loads in California. But the idea behind it is very straightforward. So during the middle of the day, especially when the sun is shining, solar systems generate a lot of electricity. At the same time, many facilities aren't using as much power. So we end up with more energy than we need. So what do you do with it? As we move into the evening, solar production drops off, but the demand rises. People go home, buildings are still occupied, equipment's running, electric vehicles are charging, people are turning on their air conditioning to a different level because they're going home, lights are coming on, and so it creates a sharp increase, and you see this in the actual curve. And so all of a sudden, boom, you get this surge. And what do we do with that surge? Because electricity has to be used at the exact moment it's generated, the grid struggles to keep up with that change. And so that's what leads us to higher costs and reliability challenges. Batteries solve this timing problem. It really is the key. And by charging the batteries during the day when the energy is plentiful and then discharging them in the evening when the demand is highest, it makes the most sense. And we can demand mitigate in that fashion. So in simplest terms, energy isn't really scarce. It's just available at the wrong time. So we'll discuss more about that here shortly. So what is energy storage? Well, at its core, energy storage is about producing energy at one point in time and using it later when it's more valuable or more needed. So there are many ways to do this, depending upon the application, whether the goal is resilience during outages or peak shaving and reducing the demand or really forming the grid. These are all things that we can accomplish with a BESS relative to what you see today out there and before batteries have become as popular as they are becoming now, you see hydroelectric dams, and hydroelectric storage is 95% of the global energy storage capacity that's out there today. But it's not really very scalable. You can't put it up next to a shopping mall. You can't put it up next to a hospital that's being built. So it's limited by its geography and can't be deployed quickly and everywhere. Approaches would include like a gravity system. We take a weight, we drop it, we capture some energy, a flywheel system where we actually spin a wheel really quickly for short durations and then it creates energy. And then thermal energy storage, like us down here in the right hand corner, these are molten salt systems, which essentially store the heat from the solar generation and then they convert it back to power at a later point in time. All concepts that are solid, but the best concept really comes down to the batteries, and we can go pretty much anywhere. And that's the beauty of a battery energy storage system. It's rapid response. It can deliver you the ability to take that energy and precisely control it and deliver it where it's needed and optimize the strategy in the way it's being used. So energy storage makes sense right now for three simple reasons. First, renewables are at the lowest cost form of generation. When you look at it with nuclear, wind, coal, and then even combined cycle gas turbine, it's the lowest cost generation when you combine a battery and a storage system. Second, the battery costs and the component hardware costs overall is falling fast. A little bit like LED. Years ago when you had the thermal sink, you had the actual chip, you had the optics, and you're putting this whole thing together. You ended up with a package that was over $100 a downlight, and now a downlight you can buy for $10 to $20, or if you buy a higher grade one, it's more architectural, of course. But it's similar because those costs came down, and it became reality that you were able to put these in and have them make sense in the commercial application. Same thing's happening here with storage. And then if you look at the size of the market, it's in the trillions. And relative to the battery energy storage market, we think it's about a $21 billion market. And about 10% of that is in the commercial industrial space. So $2 billion in this space. And that's really where the system you're going to hear about today is optimized. We're built right in PA, as I mentioned earlier. We qualify for some tax credits, and we also uh, can help mitigate the demand for a commercial industrial business that can show energy returns in less than 4 years. So it's a tremendous opportunity here for us to have you guys earn some additional money potentially if you're an agent or if you're installing it or if you're a distributor. It's a market that's just going to continue to grow. So let me pause real quick, and if there's any, were there any questions in the chat, Amy?
Yeah, we have a couple. One was, see if I can pull it up here. One was from Steve and is asking if we have relationships with the data center, the building data center folks in PA.
Yes and no. So, we do have relationships. We have relationships across the nation because all of our fabulous reps that we have certainly work with the folks, whether it's a GC, an EPC, or an MEP, and our own direct team also works with those entities as well. So I guess it would depend specifically what you're trying to gather, but we could talk separately about that. And I would encourage you to speak with your regional manager, which in PA would be Clarissa Hernandez. Anything else there?
Y- Yeah, I think the other one might have just been a comment from Steve Kurtzman, which just says ROI payback period. Steve, I don't know if you were pointing that out or if you were asking that question, but
Yeah,
if you
that's good. That's a great question because there is an ROI. We have with our NRIQ the ability to do performance modeling that can help to establish that. We also have applications engineers that can look at that, and we're going to show you a couple of examples of that today. So Jennifer's going to cover some examples of an industrial and a school customer and what those paybacks look like. But it's absolutely a good question. And we take the interval data from the customer in any 15 minutes in the day, which can cause their total demand charge, and we can model it up to show what these systems can do and establish the payback. Hopefully that helps.
fantastic. That's all we have for right now. And if you guys
Okay.
have any questions along the way, just be sure to put them in the chat.
I'd like to introduce my colleague, AJ Friesen. He's our VP of Energy Storage. He really runs the entire side of that business, which we opened up the factory just down the street from the core business where the inverters are made this past year, as I mentioned. And we're excited because AJ comes from this space. So he's a lot smarter than we are about it. AJ?
Yeah. Thank you, John. Yeah, I wanted to continue on a little bit with what John was showing, and what he was showing was the opportunity for energy storage. And what I wanted to take you through a little bit today was first was why does that opportunity exist, and then how we can meet that opportunity with Entershed. But let's talk about briefly about why that opportunity exists. So first and foremost, it absolutely does in some cases exist because of government incentives in places like California and places like Illinois. There's places like Massachusetts and Texas as well. There's a lot of government incentives that are pushing this, but that's not the only tailwind for energy storage. Utilities and private enterprises have also really started to push energy storage. And John mentioned it briefly, the reason, but a lot of it has to do with the duck curve, which I'm showing here, the chart on the right, or on the left rather. So this is an actual illustration of what's happening on the California grid on a typical spring day, sometime in March to May. And what you can see is the load on the grid actually goes from, around between 15 and 20 gigawatts to almost zero at noon. And this shows throughout the years as the penetration of renewables like wind and solar have started to add more and more to the grid. This shows what's happening over time. But in 2023, load on the grid essentially hit zero on some spring days. Then what needs to happen, as John mentioned, is people get home from work, they start, turning on the lights, they start their oven, start doing laundry, for example. What you can see is the load on the grid begins to spike around 8 p.m. Also the time when say solar and wind are no longer generating as much. And what this means is that the California grid has to ramp from 0 gigawatts to 25 gigawatts in the span of about 8 hours. And the kind of dirty little secret behind this graph is that even though the load on the grid is zero, for a portion of the day, the utility has to maintain all of that generating capacity, which is shown here as the red line. And so for large portions of the day, the utility's own generation is sitting there completely idle. And this is where the utilities have started to really latch on to energy storage because rather than having that generation sit idle, they could be running it and storing that energy in batteries for dispatch during these peak times. Allows utilities to do is either lower how much overall generation they have and then also more fully utilize the generation that they have. And so storage, so utilities have really latched onto this. They're pushing their own incentives, time of use rates and demand charges are the ways that utilities use to incentivize either the times that we use power or incentivize, how we use storage, things like storage and solar, for example, to change our power consumption. And so a good example of a project, this was an independent power producer that put a project in, Edwards and Sanborn. That's a 3 gigawatt hour storage facility, a single facility. And they're selling power to several utilities, City of San Jose, SoCal Edison, PG&E, for example. And so utility, it's not just government. What I want you to take away from this is the opportunity is not just driven by government incentives or state mandates, but utilities and private enterprises are also putting a significant amount of effort into the adoption of energy storage. And that duck curve, I was talking about California, but that duck curve exists in many different places in the US. I'm showing here an example of the Northeast ISO, for example, also has a similar duck curve starting to form again as renewables like wind and solar, which can be intermittent forms of generation, show up on the grid. I'll talk a little bit about behind the meter versus front of the meter use cases. So it's pretty much exactly what it sounds like. Entershed 2.0 is designed, specifically for the kind of commercial and industrial market. It does work in front of the meter cases, but it's ideal for behind the meter use cases in commercial and industrial applications. All that means is that it fits really well on the customer's side of the electric meter. Again, we are doing front of the meter projects with Entershed as we speak. And so I don't want you to eliminate either one. But you might hear behind the meter and front of the meter, and there are slightly different use cases depending on which one you are. Behind the meter use cases, so on the customer's side of the meter, include things that save or make the customer money, essentially the end customer, right? So demand charge management is an example. You might hear people talk about peak shaving. That's what that is, and that will save customers money from their utility bill. Energy arbitrage or load shifting, John mentioned, is storing energy at one point of the day and dispatching at another point of the day. Again, playing in between time of use rates, for example, if your commercial customers on a time of use rate. And then resiliency. A lot of folks like to put in storage because again it saves or makes them money, but there's also kind of this other benefit where the energy storage can keep a customer's facility up and running during a power outage. I know lots of states, Texas, California, the resiliency of the grid has been dropping as demand on the grid has been going up. So having an energy storage system to keep your operations up and running, maybe you're a grocery store, having a storage system to keep your refrigeration up and running during a power outage so you don't need to throw out produce. That's an important benefit for some folks. And so resiliency is a big benefit for a lot of folks, maybe a little bit harder to monetize than demand charge management and energy arbitrage, but it's an important benefit for a lot of folks looking for energy storage. And then grid services. So grid services, we put this in the behind the meter use case here because what's starting to happen is utilities are paying end customers to provide services to the grid they would normally count as front of the meter use cases. So utilities are paying retainers, for example. In some cases, there's pilot programs in Con Ed, a PG&E, for example, where utility will pay a retainer for access to the storage system. So if there's issues on the grid where they need help with frequency regulation or they need help with voltage support, the utility can call on an end customer storage system to provide that support. And that's another revenue stream, which is why we've put grid services in the behind the meter use case, because that's another revenue stream from these systems for the end customer. And so a lot of storage systems, there are these large containerized, compartmentalized storage systems. They take up a lot of space. The inverter isn't necessarily close to where the batteries are. Fire suppression takes up a lot of space. HVAC or liquid cooling is a whole compartment on its own. But what we've done with Entershed 2.0 is really create kind of an all-in-one solution that's built off of these three very simple kind of primary building blocks. I like to call them our Lego pieces. And so one of those is the enclosure. We've got 4 different sizes of enclosure, and I'll show you that. And then we've got a 15 kilowatt bidirectional converter and a 2.5 kilowatt hour usable storage cartridge. That's where the batteries are that provide the energy. And so out of these 3 building blocks, these 3 Lego blocks, we've created a very, very scalable energy storage system that allows you to really size it in any way that you need to meet your customers' needs. And so we take those building blocks and we've made this 30 kilowatt, 50 kilowatt hour shelf and this nominal 2-hour shelf, and the 30 kilowatt, 100 kilowatt hour shelf, which is our, for lack of a better word, nominal 4-hour shelf. And then we've put those into enclosures, and this is we've got 4 different sizes of enclosure. This is an AC coupled energy storage system. We do all the combination of these different shelves in the enclosure, but what we've done here is you can populate that enclosure with as many of these shelves or as few of these shelves as you need. And so if your customer wants a 60 kVA system, you can provide them a 60 kVA system. If your customer wants a 90 kVA system, you can provide them that. And you can do that every 30 kilowatts. That's unique in the industry. The version I showed you earlier, the kind of containerized energy storage system, that might only come in 125 kilowatt blocks. It might only come in 1 megawatt blocks. So in a lot of cases, you'd either be oversizing or undersizing your storage system. With our modularity and the granularity that we're providing here, we're allowing you to be able to meet your customers' needs anytime and every time through the sizing. We're also a step ahead when it comes to safety of the energy storage system, fire safety of the energy storage system. So Entershed 2.0 will comply with the latest NFPA 68 and 69 standards. Those are ones that AHJs have just started to ask about somewhat recently. Certainly in California they're starting to in other areas of the country. Those are explosion and deflagration standards that Entershed 2.0 will meet, as well as a new NFPA 855 standard. There was a new NFPA 855 standard that dropped just at the end of last year. Entershed 2.0 will meet that. What that standard did is actually create the requirement for a new large-scale fire test, one that up until now has not been included in UL 9540 or UL 9540A, but NFPA 855 is mandating that. We are actually in the process of doing that testing with Intertech. And so we're excited to be ahead of the curve when it comes to these safety standards, and it will make your projects with Entershed 2.0 much easier to permit through an AHJ than, say, somebody else's storage system. So a summary, this is what kind of what we get at the end of the day. Again, we've got these 4 enclosures, and we've got our 30 kilowatt, 50 kilowatt hour, or 30 kilowatt, 100 kilowatt hour shelves, which allows you to mix and match really to almost any size you need to. Again, this is our Lego system, and we can put it together very quickly in many different configurations for your customers. Of course, if you've got a system, the largest one we're showing here, the largest enclosure is 300 kilowatts and 1 megawatt hour. If you've got a system that's much larger than that, but we can accommodate that. We just put multiple of these units side by side. We are, for example, now shipping multi-megawatt projects using this technology. So we can do large projects, we can do small projects, and and the system is ultimately configurable for what your customer needs. And John mentioned we're doing this in Bethlehem, Pennsylvania. So that's a photo there on the left. There's Congressman Ryan McKenzie came to visit our manufacturing facility in Bethlehem, Pennsylvania. We've been manufacturing emergency lighting inverters there for 60 years. And we're continuing that tradition with storage. We're very excited to continue that tradition with energy storage. We believe we have the most American content of any energy storage provider that's selling into the US. And we're very excited to continue that tradition. These images are of our first generation product, but our second generation product will be manufactured there as well. And so the three pillars of our value proposition are: one, capability. I've talked a lot about our Lego set that is very ultimately configurable to your customer's needs. Our density and levelized cost of storage. So it's a very, very dense design. We've paired the inverter very closely with the batteries. We don't have a large HVAC or liquid cooling section. We're air cooled, which saves a lot of space. So very, very dense, very low cost of storage design, and reliability. So these are designed and manufactured in the US. It's a robust and fault resistant design. And one thing I like to point out about the reliability aspect of this as well is we've got service coverage throughout the US. This is a unique position also in the energy storage world, because we have the emergency lighting inverter business, which emergency lighting inverters need to be checked once a year. We have service personnel throughout the US that will also be servicing our energy storage systems.
There's a
Sure.
couple questions, AJ. So Corey asked, and maybe this is a me question, but what specific obstacles exist right now that make it difficult to use BESS for emergency load backup in lieu of having an inverter plus a BESS? Really, I'll give my answer to it and you can expound on it. This is really kind of a roadmap thing and what we think we can do with when you layer in the NRIQ software, you can mortgage off shelves. And again, our design is with shelves so that they can be used for different things. So we could have a shelf that's used for UL 924 emergency lighting load. We can use it for elevator backup. We could use, we can quarantine off essentially energy specific for that within the BESS configuration. So from a constraint topology, there is really none, but from a perspective of UL and other things, this is not right now a UL 924 certified approved device, but there's no reason why it couldn't be. And so it is something that we're looking at from a roadmap perspective. And eventually, if you could keep one of these units outside that handles not only the resiliency, but also the load backup in a facility, for example, in California, you might have a nursing home requirement that has 96 hours of resiliency for critical loads that's required. Well, if we take that energy that's required for those applications and reserve it for that instance, we can parse out the energy over time. And so that everything doesn't just get loaded to whatever, it can go to specific load designs. And that's what the software does. So where we're really excited about it is the roadmap is just going to continue to evolve this product line. AJ, you want to add to that?
Yeah, no, that's exactly right. I would have said pretty much the exact same thing. It comes down to number one, listings, and then number two, how we partition the energy between some of these other use cases and an emergency use case. But it's definitely something that's on our roadmap. I talk to our chief technology officer, chief product officer weekly on the possibility of making a product that meets both requirements. So.
Ahmad, you asked, can we share the slideshow? We will be sharing that. You may have joined us just a little bit later, and we said that, but at the beginning we did say we will share this to anybody that's registered. So that'll come over. Do you have the ability to connect directly to solar panels, AJ?
Yeah, so we are not a DC integrated system. We're AC. And so what would happen in the case where you're using solar panels, they may be on the same AC bus. You would have your solar panels and your solar panel inverter, and then our storage system could go on the same AC bus, but we're not a DC integrated system at this time.
There's a question here, and there's a question here about what battery chemistry you're using. It's LFP or lithium iron phosphate. So it's a form of lithium ion, which is in your cell phone, for example. But the iron and the phosphate stabilize that lithium ion, and so your platelets are less likely to be flammable. In fact, I don't think we know of a fire that has been directly connected to LFP. That form factor has generally been accepted for over 50 years in the telecom industry, and it's basically a prismatic or rectangular form factor. And as you can see in these pictures here, and then back to AJ's schematic design, these are a rectangular form factor. And so as long as we have that form factor, it's kind of future proof. That's what's unique about this system, because even if a different chemistry comes down the line, like sodium ion or something else that makes more sense, we're able to put it into the system. In fact, we can even intermix. So as long as it's delivering the right voltage across the string, we're in good shape. So that hopefully answers your question there. There's another question here, AJ, about does the battery meet domestic content rules to get the extra 10% tax credit?
Yeah, we're looking at that actively right now. Actually, I'm assuming you're asking about the production tax credit, the PTC. We're looking at that actively right now. The short answer is yes, but we're having a third party evaluate our supply chain for that. So um, we're looking at that presently.
Does Myers handle the required utility submittals covering drawings showing integration with solar, etc.?
So the answer is no. We don't have project engineers on staff. We have consultants that we've worked with in the past and that we're currently working with, where we can provide some guidance on that. Ultimately, the project EOR would have to be responsible for that, and that's not a position we're taking.
And I think that's it. But now, Jennifer Lawrence, who is a movie star of sorts, I think, is going to take over. And go ahead, Jennifer.
Everybody. Just let you know, I'm battling a little bit of a cold, but I'm excellent. Thank you, AJ and John. There was a lot of great questions. One of the things that needs to happen here, though, is these batteries need to be smart. And with any renewable, that is energy management system is the next critical component. But before we dig into this, because it seems we've got a lot of technical stuff going on, let's talk about a story. So if you notice, I was born with a name that quite a few people recognize, but the benefit is I get upgrades, right? I was in this old quaint hotel in London and it landed me in the largest suite. I was exhausted and I thought, this is overwhelming to manage all these lighting and shades. I just wanted to lay in bed. But I noticed on the bedside table, there was an iPad that controlled the entire room with one system, right? Such a smart solution for travelers. Managing the room is like what an energy management system is, but on a larger scale with different components. It's just smart, period. Our NRIQ, how this does it is it knows what to do and when to do it. Our NRIQ is magic. It's monitoring and controlling the system. It controls all things within your facility that's using the power. Like I said, NRIQ is more than battery storage. It can be used for controlling EV chargers too. NRIQ makes your system smart by knowing what your microgrid is doing. And I hear you ask, what's a microgrid? Well, let's talk about that. It's a group of power sources all controlled by a system that includes energy management software and a switchboard. So the microgrid is grid forming system. Here's a basic schematic of a microgrid on a property. Power from the battery can be used with or without power from each other side, as you see here via these lines. Our NIQ allows you to control the sources, and the communication with the switchboard will determine which source of the power is going to be used. So let's say you got energy storage on site, it can control that. It can control when you charge the battery. It can control when you don't charge the battery because you want to charge it at lower cost for utility. What happens when you control those things is you're in complete control of your energy, and you can decide when you want to take energy off the grid or put it back on. A lot of the programs that have money to put it back on, you get paid for it. So the next thing we need to think about is making revenue. So I come from a background in renewables, and aside from your ROI or total cost of ownership, revenue generation is another story. We like to look at defined revenue opportunities. So Our NRIQ system allows for a better total cost of ownership with EV charging, particularly by lowering the cost of operation for peak demand charging time. Additionally, all these cars that are getting charged, whether it's in California, Phoenix, or wherever you are, there are times those charging stations don't have enough of their own to supply from an energy perspective and get the output needed. That output's really critical, so you don't have to sit at that charger too long. With our system, you will have the best chargers on the block because you can supplement that power, which is an excellent for greater quantity return of customers to your site. The other big revenue generation out there is carbon credits. Our system will allow you to do the reporting so that way you can capitalize on your carbon credits, potentially allowing for revenue of high six digits to a million, depending on the size of your facility. Now, let's talk a little bit about the markets. In a few markets, we see more demand for Entershed batteries and the use cases related to the benefits of the renewables, right? Industrial customers, no brainer, high demand charges. We're able to help a company reduce their operational costs and become a company that has a story to tell for being better for the environment, because a lot of the industrial customers have a hard time in the environment, right? Military and government. AJ was talking a little bit about resiliency. It's very critical for military and government to have that for security. And this particular project that we worked on up north also did it because of extreme weather events. Because our system will function even if generation, say your solar, your wind, or diesel, is partially unavailable. We also see schools and universities going to solar because of state mandates and board requirements. But having solar is only going half the way of being energy independent and freeing up the overhead costs for more. So it's a natural pairing to have battery energy storage and energy management system on a campus. All right, let's talk about rate components. And AJ had talked a little bit on his section about demand charges and other behind the meter use cases. A lot of utilities have these special pricing programs, and energy storage can save you on your energy bill. With demand charges, a facility's utility bill can double or triple depending on the region because of the peak demand rate. This amount can change from month to month, given that it's based on a small period of time in which it's recorded. With NRIQ real-time monitoring, it allows for a fast switch to the lower cost of energy stored, so no surprise large utility bills month over month. Now, when we look at time of use charges, because PV is being used, the PV mitigates more of the prices, right? Now, but you still want to be able to schedule when that battery is going to be used to offset when the PV isn't going to be used to keep your operational expenses lower. John, do you want to go over this one?
Yeah, sure. So this is an example of a industrial metal fabricator that AJ pulled up and was working with last year. And when we looked through the total energy bill, the interesting thing here is if you put a BESS system on this, the demand charge, as we examined the peak and off-peak and super off-peak, the total demand charge was $512,000, which is 51% of the total, which is almost $1 million a month. And so applying this to the demand, if you can reduce your energy costs by as much as 50% or more, it's a no-brainer. And in this case, the simple payback was less than 3.5 years. You want me to go? Okay. And then there's an example of a middle school as well. A little bit longer cycle because they have less peaky loads, when you look at a school. But we've had a couple schools that have been done already with these systems. They make sense. Primarily California is where we've seen them, but other places that we've been putting projects together and proposals together across the country. And so there is a payback. It's a little bit longer because there's less peaky loads, but still makes sense. So different types of commercial industrial type applications that you can apply, and we can help you to do this with the EnterIQ software. So kind of tying a bow on this and going back to what AJ was talking about earlier, it comes down to these three pillars. It's our capability, our density, and our reliability. And what does that mean? So capability, let me make sure that everybody's clear on this one. If you have a containerized solution, what AJ was saying is you might have a 125 kilowatt or a 250 kilowatt block that is available for your solution set. We're at 30 kilowatt, 100 kilowatt hour. And that is completely modular in the design compared to our competitors. What does that mean for you as an agent or you as a contractor or distributor? It means less cost. And I don't know about you, but sometimes cost is a factor in the construction industry. So that's a big deal. And we had a real use case up in Portland, Oregon, I think it was, where an Eaton solution was being looked at, and they had a 125 kilowatt, 250 kilowatt hour BESS system that they required for this application. And in order for the Eaton to do that, and I'm not picking on one manufacturer, but theirs is a containerized solution. They had to use 2 of those container solutions to get to the number of kilowatt hours that they needed, where we had to use 1 of our cabinets. And so that equated in about half of the cost from a hardware perspective. And when you consider the fact that there's no crane required on our units because they have forklift pockets, that was an incredible advantage for the contractor and for our agent that was putting that project together. Density is important, and energy density. We have one of the most dense systems. What that means is we have a smaller footprint. So just like with our inverter products in our Nova series, where we have the smallest footprint in, say, a 3-phase 50 kVA or 60 kVA system, it's very similar here. These units are even though they're big, and we showed you a picture of it, I'll go back to it here. They are, and this is me here, and you're looking at, I'm about 6 foot tall. These are very large units, but they are less large than our competitors, and that can be important. So, and from a reliability perspective, and when we put these fans on here, and that cooling is different than if you put HVAC in the system, for example. Liquid air cooling, which is HVAC, goes into that entire containerized solution, and it hopes that it gets the area chilled that is heating up. We don't hope. We have an exact strategy and we have a plan. So the cooling is done with these fans, and these fans put the cooling exactly where they need to be, where the hot spots are, and they move the air through that system so that it continues to operate. What that means for your customer is increased reliability. Uptime is everything on these units, and we feel we've really got that piece in check. What we didn't mention about the fact that we brought this product back to PA is that we are able to conduct these things with our Gen 2 product quicker than anybody else in the industry. And that's what we're really excited about it. So the typical industry is anywhere from 6 to 12 months unless somebody's stocking a bunch of standardized units. What we told you about is ours aren't standardized. They're really made to order and modular. But we'll be able to produce these instead of 6 to 12 months, we're going to be able to produce these in 12 weeks. That's going to be industry leading, and the US content gives us a significant advantage. Many of your customers probably don't want to deal with a foreign entity or have security issues with somebody in China reading the registers on your unit, and we don't require that. So this is a benefit of the Myers system. We're excited about it. We really feel that we can do some damage in this space. We feel you can help you guys with revenue. If you look back at this first opening slide here, this is an actual system up at an Air Force base in Northern California. And that system was 3 megawatt, 12 megawatt hours. And it was about $5 million of revenue for that agent. That's significant. So if you guys want to get into this, please talk to your regional business managers. It is a separate agreement. If you're a distributor, if you're a contractor, an engineer, and you want more information, we're going to have level 2 and level 3 training upcoming. And we're really excited about what we're doing in this space. So it's the future, it's here, and it's now. Thank you for taking the time. We're going to take a few minutes and go through any questions here. Amy, did anything come up while I was rambling?
Well, AJ did a great job here answering questions while you were rambling, but it was not a
Yeah.
ramble, John. It was not a ramble. But the one question here that I don't think got answered is from Steve again, which is what is the max ambient temperature it can handle? And maybe that's a question for AJ. Not sure.
CC. Now it's going to throttle down before that. AJ, maybe you want to elaborate.
Yep. Thanks. I was working on it as we were speaking. So
Oh,
yeah,
sorry.
the inverter starts to derate at 45 degrees Celsius. So it'll run at 100% until 45 degrees Celsius, and then it'll start to derate linearly to 0% at 60 degrees C.
Okay, I think that's all the questions that were put in the chat. All the other ones have been answered, so I think we got that. One came
Can
in
they
here
be
from
stacked?
Ariel. Yeah, can they be stacked? Go ahead.
No, these were not designed to be stacked. There's a ton of challenges that stacking them brings, including higher cost, higher O&M costs, as you can imagine. Again, John showed these images. These things are, 10 to 12 feet high. So O&M at 40 feet in the air, it can be tricky. So cost, O&M costs, and then seismic issues with that as well.
Will you please
Harmonic
explain the
output.
harmonic output of your system?
Yeah, off the top of my head, I apologize for not knowing this off the top of my head, but I believe it's less than 3% total harmonic distortion.
Is that in our spec sheet, AJ? I don't
I
remember.
believe, yeah, that should be on our spec
Okay.
sheet. I believe it's less than 3%.
Yeah, so if you go to bess.myers.com, or you go to the Myers website and then go into or smart energy storage systems, you'll be able to find our most recent documents, and that can help you both on EnterIQ and Entershed. Anything else, Amy?
No, I think that's it. I don't know if you wanted to mention with Ariel's question on saving on real estate in the stacking, but is just how much smaller our units are. I know you kind of mentioned it when you went through it, John, but how much smaller our units are than what, some of our competitors are. So they're already saving on real estate. Maybe that's obvious. I don't know, but I just
Yeah, I
thought
mean,
to
it could
mention
be
that.
it could be up to 60% smaller. It depends on the equation. AJ, I don't know if you have a better handle on that, but that is significant space because again, a container is like a big shipping container, right? So imagine the big shipping container, and then imagine something that's roughly a sheet of plywood in terms of the actual cutout of the unit on the smallest unit, and then about what 3.5 feet wide and 4 feet deep on the shortest cabinet, right, AJ?
Yeah, yeah, that's right.
Just to give you a sense. So the biggest cabinet I think is about 11 feet tall, but again, all we're doing is increasing the depth. So it's still relatively skinny compared to our competitors, if you will.
Yeah, thanks. I just thought that was maybe important to point out. Any other questions? Are there any use cases of using a BESS versus a diesel generator? Steve, you're full of questions today. Love it.
Yeah, yes, absolutely. There are a lot of folks that are doing that. We've seen it on a number of projects. There's a couple things that can be a little bit trickier if you're setting up a microgrid doing that. Some generators have pretty noisy output. And so if the generator is running the microgrid, if the generator is forming the grid, that can get a little bit tricky, but it is possible, and we've done it. If the energy storage is running the grid and the generator supporting on a droop curve, for example, that's a little bit easier. But yeah, absolutely, we are installing projects right now that are both energy storage and generator.
Okay, I think that wraps then the question section. If there's anything else, we're here to answer your questions. Reach out to your original business manager or your contact at Myers, but we want to get your questions answered. We don't want you to just wonder and sit there and not know. So please reach out. We're here to help you.
Yep. Thank you all for your time. Have a great day.